Today we're breaking down the pieces that make up connections, the connectors and the transceivers that allow cables to talk to one another. Now, I would like to say that in this video we're only going to go over some basic connections. We're going to do a much bigger deep dive, more advanced dive into the plethora of fiber connections that there are and what they can do. This one's really just going to be like kind of a beginner guide to connections and transceivers. Simply put, connectors and transceivers are the endpoint and the translator of a network's connection. Connectors are the physical part at the end of the cable that allow them to physically be able to connect to a device. The transceiver is what converts the optical signal or the electrical signal so that way cables can actually talk to each other. If it wasn't for this, then cables would basically be useless. Okay, so let's think of it like this. Connectors and transceivers are like adapters and translators for a conversation. The connector is like a headphone jack. It lets you plug in, it physically links you. While the transceiver is the translator that converts what you're saying into a different language. This is what's turning the electrical signals into light or back again. For a little bit more of an in-depth explanation, let's look at some basic connectors for copper and fiber cabling. Copper Ethernet cables use the RJ45. This is the most common network connector. It's used for the Cat5e, Cat6, and higher. It's 8 pins, 1 click, and then you're connected. For fiber connections, we have the LC, SC, and ST. The LC stands for Lucent Connector. It's a small form factor, easy to use, and popular in modern fiber networks and patch panels. SC stands for Subscriber Connector. It's larger, push-pull design, still used in enterprise setups. And finally, we have the ST, which stands for the Straight Tip. Older, bayonet-style twist connector, mainly legacy gear and industrial setups. They all serve different purposes. The RJ45 is meant for switches, routers, and PCs. The LC is meant for data centers and high-dense panels. The SC is for enterprise fiber networks, and ST is legacy fiber systems. Now, how these fiber connectors relate to single mode, multi-mode, we've already kind of talked about that in an introduction, and I'll put that video up here. But don't worry, we're going to have a much more in-depth fiber-centered video coming out really soon that goes a little bit more advanced with all the different connectors, when they're used, why they're used, and the main difference between all of them. Okay, so now let's talk a little bit about transceivers. What they are essentially is just a converter. They convert electrical signals into optical signals or vice versa. It's what allows data and determines what type of data is traveling in your network. Essentially, like you have fiber coming into the house, you have a converter that turns it into an electrical signal so that way you can get it to your computer. The most common types, and I'll try to go through this kind of slowly because I know that it can be easy to get confused, are SFP, SFP+, QSFP, and GBIC. SFP stands for Small Form Factor Pluggable, supports up to 1 GB per second, hot swappable, modular. SFP Plus is Enhanced SFP, up to 10 GB a second, common in enterprise switches. QSFP is Quad SFP, 40 GB a second or more, used in data centers and high performance equipment. GBIC stands for Gigabyte Interface Converter. It's older, bulkier version of SFP, now largely phased out. Each transceiver has a port and an interface type. LC, SC, RJ45. These determine how devices are going to connect and communicate with each other. Is it going to be electronically or is it going to be optically? A typical setup of how these things might work together would look like this. For fiber, we would have an LC connector with a SFP transceiver that goes to a switch port. For copper, we would have a Cat6 cable that goes to an RJ45 that goes to a direct port on the router or switch. In short, connectors attach, transceivers convert, and together they make a complete circuit. Now for compatibility and speed, you want to make sure that you always match your transceiver type to the device and the cable. For example, wrong fiber types like single mode fiber and multi-mode fiber will equal no signal. Wrong wavelength equals no communication. Incompatible SFP won't register. Now, we are going to have more advanced videos in the future talking about single mode, multi-mode, wavelength, and all that stuff. That's going to go way more in depth with that. This is more just kind of an introduction to it all. Also, it's important to note that most modern switches can detect SFP, but other third-party cheaper ones can cause link instability. So to wrap everything up, the connectors and the transceivers are the small parts that make big communication possible. And I'm talking big WAN level communication possible. We have the RJ45, the LC, SC, and ST. These are the physical connectors that get plugged in. And then we have the transceivers, the SFPs, the SFP plus, the GBIC. These are the things that translate or convert the information. Together, they form a complete circuit. Okay, so that's it for the video. I hope you enjoyed it. If you did, please smash that like button, subscribe so that way you don't miss out on further content. And as always, work with what you got and build what you need, and I'll catch you in the next one.